We're going to look at Pythagorean theorem, and this question is like a problem-solving question. So we'll go down and take a look. We'll read the question first and then kind of tie it to this diagram here. Two 30-foot wide highways meet at right angles. So we're talking about this highway here, whoops, not so nicely drawn, and this highway here, they meet at a right angle. A signpost is 15 feet, okay, so here's our signpost, from the edge of one road and 35 from the edge of the other. How many feet from the center of the intersection is the signpost? Okay, so though it does not look like it, if we were to move this 15 over here, we're kind of setting up our right angle triangle relationship here. The 15 essentially pulls us to here, and then if we were to duplicate this, and this is not quite the scale, we end up with two triangles. So we know that because this is 30 feet wide, okay, and let's draw this a little more permanent. Because this is 30 feet wide, if we're going to the center here, that means we're going 15 feet this way, okay? And that same goes for this highway here. If this one is 30 feet wide, then we're looking at another 15 feet here. Sure. So, in order to draw out this in total triangle here, we're going to extend this. So we have 35 and 15 to get all the way over here. So 35 and 15 gives us a 50-foot horizontal length, and then to go vertical it's 15 plus another 15, so we're talking about a 30-foot vertical length here. Okay, so if we were to redraw this triangle, let's see if I have a nice one. Here we go. If we kind of try to redraw this here, our measurements are going to be 50 feet and 30 feet. Okay, and the question is, how far is it? If this is our sign, maybe it's like a stop sign. Doesn't make sense for it if it's not on the road, to the middle of the highways. This is our unknown value. And in terms of Pythagorean's theorem is one of the legs squared plus the other leg squared is equal to the hypotenuse, which is c squared. Now in this case, we've called our c, that's our x value. We could call it any variable really. And the a can be any of the legs, so we'll call this one a, and we'll call this one b. So we'll replace b with the value of 50, and we'll replace a with the value of 30, and c, or x, is still our unknown. So a is 30 squared plus our b is 50 squared is equal to, and we'll call this x. Okay, so we've replaced everything. We've even replaced the c with the value of x squared. And now this is simply just isolating for a value of x. So 30 squared will give us 900, plus 50 squared will give us 2,500, is equal to x squared. When we add those together, we should get 3,400, I believe, is equal to x squared. To move the square to the other side, or to eliminate it, square root would nullify it on the right side, whoops, and then we're looking for the square root of 3,400. So the square root of 3,400 will be equal to x. So x is equal to, as we bring up our lovely calculator here, square root of 3,000, let's delete that, 3,400 is equal to 58.3. So approximately 58.3, and these units were feet. So the distance from the signpost in our question is 58, and that makes sense because the hypotenuse should be longer than our longest side, and this longest side was 50, this one is 30, so a little longer than 50 makes logical sense for an answer.